CR, please inform others to join soon so that we can start. CR is there? Not there? Archita, you tell all others to join soon, okay? We'll wait for 5 minutes and then we'll start. Please ask everyone to join. Are you there, Archita? Mohit? Mohit is there? Please ask everyone to join. We will start in 5 minutes then. Good morning, everyone.
Good morning, ma'am.
Good morning. Okay, so yesterday we have discussed about signature analyzer. उसमें किसी को कोई प्रॉब्लम है तो बताओ अभी तक. Signature analysis we have done yesterday. So if you have any issue in that, let me know. Signature analysis along with the other analysis, this is a part of your output response analyzer. Okay. So what are the other output response analyzers? और दूसरे कौन कौन से हैं? वंच काउंट, पेरेजी काउंट, सिंड्रोम काउंट. These are the others, right? Transition count. And signature analysis is also one of them. ठीक है? So signature analyzer, what it does, you have a LFSR. LFSR जो होता है, in that LFSR, whatever the contents of this LFSR are, those contents are going to decide what will be the polynomial exponential. Okay, Px. So this side, this is your Cn. So total polynomial will be expressed in this manner. I is equal to 0 to n ci xi. Sorry, x raised to power I. This is how you will be representing the polynomial. Now the set of inputs is going to represent the generator
Excuse me, ma'am.
polynomial.
My PPT
हाँ
is
बोलो.
not visible.
अच्छा अच्छा हाँ wait sorry. So it is somewhat like this. You have LFSR and this is your Cn, coefficient of x raised to power n, and C0, coefficient of x raised to power 0. And here you are having the feedback, so it might be external, so XOR gate can be here, and it might be internal where XOR can be in between the flip-flops. Okay, and there might be a connection. So wherever the connection is, we will put that coefficient is equal to 1, CI coefficient. Otherwise that coefficient is 0. If something is 0, it means the corresponding exponent term of that x raised to power n will not appear. ठीक है. सो ये आपका gx था, ये आपका px था. सो द स्टैंडर्ड वे of calculating the signature is like this. You will just do gx upon px mathematically. Whatever you will be getting, that is your qx. So that's the quotient that will be there in the output. जो LFSR है, you will be having 1 bit output that will be appearing after the number of cycles plus 1. जितने flip flop हैं, the number of cycles plus 1. After that the output is valid, so that output is going to decide the uh, qx polynomial, which is nothing but the quotient polynomial. Okay. Yeah. So the quotient polynomial is getting decided by that. Just wait a minute. And whatever is left over, that leftover is rx. Rx is the remainder polynomial. Okay, you will be having the rx polynomial. That rx polynomial will get stored in your LFSR only. So using these two, your signature is compiled. Signature of that particular pattern, input pattern, is compiled. So what is the input pattern? The input pattern is represented by gx, because this is having the set of inputs, right? Sequential inputs. So the input pattern is given by gx over here. So I also told you how to calculate the next set of states for flip-flops. You will just be using wherever the XOR is there, you will just calculate that, and after that calculation the updated value for the next cycle will be appearing. Okay, so for every clock cycle you will be calculating the new set of values. Here I just want to tell you one thing. आप में से काफी बच्चे ऐसे पिछली बार भी कर चुके हैं, अब की बार भी कुछ अता पता नहीं है, बिकॉज कोरोना टाइम इज गोइंग ऑन. सो व्हाट दे डिड, आई हैव गिवन देम द सेम एग्जांपल. ये एग्जांपल मैंने उनको एग्जाम में दिया था, and I shared the slides earlier also, so they could somehow figure out that this example is from the slides. Then they opened these slides and then they did it like this only. उन्होंने ऐसे ही किया. They calculated this. They have not calculated, they have copied. But since this is dash dash given for all these three entries, so they don't know what to do in these three entries. So they just put dash 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 for these entries, and after that they just put all these, and they have given the answer. So in this fashion, if you are going to do, you will not get marks for that. Okay, whatever is in the dash entry, that entry you have to do at your own. Fine. And most of the examples whatever I have been using, these are given from your textbook, which is Abramowitz, जो आपके टेक्स्ट बुक रेफरेंस बुक आपको दे रखी है सिलेबस में, उसी में से मोस्टली एग्जांपल्स लिए गए हैं. ये जो अपडेटेड वर्जन ऑफ योर बुक है उसमें जो अभी ट्रांजिशन काउंट का जो एग्जांपल था उसमें कुछ प्रॉब्लम थी. दैट प्रॉब्लम इज नॉट देयर. अपडेटेड वर्जन में वो प्रॉब्लम नहीं है. तो जिन लोगों ने बुक खरीद रखी है दे कैन यूज द बुक टू डू द सेम थिंग. जैसे फॉर एग्जांपल इन दिस द R0 is 1, R1 is 2 actually. Sorry, transition count na R, this is also 1 and this is 0 because this was 0. ये आपका 0 था. So these problems are not there in the upgraded version of the book which I have the latest version. ठीक है, तो वो आप बुक से एक बार देख सकते हैं. ओके, या. So now let's go to the next topic. The next topic is multiple input signature register. So multiple input signature register. These all the chapters, whatever we are discussing as a part of unit number 5, these are given from chapter number 9, 10, 11, like that. In that those chapters, these all things are given in your book. So please go through those chapters to understand a little more detail about it, and in order to check more examples related to this. So multiple input signature register. What is this? Multiple input signature register is a register just like LFSR, but this register is having multiple entry options altogether. You can see there are multiple entries for multiple bits, D1, D2, D3, Dn. All these are going as an input to the XOR gate, right? Altogether these are going as an input. So how it will be implemented? So this is how it will be implemented. You have this block, and okay, we'll discuss this a little later. Storage cell of signature analyzer is given over here. So in this cell, you can see you have a D flip-flop here and another D flip-flop is here. So this D flip-flop, actually there are two D flip-flops and then this XOR gate is like this. So this is your CI. CI is nothing but the coefficient which we have discussed in internal and external LFSR. So the CI will depend on the number of bits. It can be 0 or 1. If the connection is there, we'll call that CI is 1 corresponding to that. Otherwise, CI is equal to 0. If connection is not there, we'll call that CI is equal to 0. So it has to be like that. So in this case, since we have the multiple inputs, so we'll be using two registers instead of one register. We are using two registers, and DI entry is here through this flip flop, and then this is going to the next one, and then using this XOR gate later on. So this is the storage cell of signature analyzer for multiple input signature register. Performance of signature analyzer, it is given over here. For a test bit stream of length m, possible responses will be 2 raised to power m, of which only one is correct. Out of those possible responses, only one possible response is correct, because the signature is unique for every bit stream. The number of bit stream producing a specific signature is like this. The number of bit stream producing a specific signature is like this, given by this formula. Performance of signature analyzer. So this is the mathematical expression and some of the terms are missing. So it is better to go with the book and just to figure out what the formula is. So इसमें थोड़ा ढंग से नहीं गिवन है, आप बुक में इसको फॉर्मूला को एक बार देख लेना, चैप्टर नंबर 10 में मिल जाएगा आपको. So after the signature analyzer, we have generic offline BIST architecture. As I discussed earlier, BIST is of two types, online and offline. Online matlab with the simulation, when simultaneously the chip is going to do your own work and the BIST is going to do its work. Okay, offline means this your CUT is taken inactive and then the BIST is going to work. Okay, so generic offline BIST architecture is given in this. Categories of architecture, first one is centralized or distributed, embedded or separate BIST elements. Key elements are like this, similar to the previous one we have discussed: CUT, test pattern generator, ORA, output response analyzer. Apart from this, you will be having these also: distribution system for data transmission between all these three. So for that you need a distribution system, and BIST controllers are also needed. Okay, these are the three parts which we have already discussed, and these are also new parts which we have to discuss. So BIST controllers are going to control the activities, intermediate activities between all these three units. Okay, and the distribution system is also available for distributing the data. So this is the centralized or separate BIST architecture. So this architecture is also given in the book, and in order to know more details about it, you can read from the book. So you have the chip CUT, this is the CUT, and this is the distributed system. After the CUT, you have this distributed system. This is the test pattern generator, and this is the output response analyzer, and this is the BIST controller. Okay, so here you can see there are multiple CUTs available. आप जब BIST controller say whatever you are going to do, test pattern generation and analysis you are going to do. So there are multiple CUTs altogether, and the test pattern is given to each CUT through the distributor unit, data distributor unit, and at the receiver end also there is no direct ORA. You are having distributor unit, and then the output from the CUTs is collected to the distributors, and then it will go to the output response analyzer, and then the BIST controller is going to identify, okay, where is the problem, what is the problem. Now the question may arise how it is different from the previous one. So in the previous one, if you can check that that was online BIST architecture. In the online BIST architecture, it was somewhat like this: you have TPG, after that you have CUT, after that you have ORA. Okay, so these all three units were there. So here for one specific CUT, one specific TPG, and one specific ORA was there. And whenever CUT is going to do its work, chip is going to do its work on board. All these test pattern generation and analysis, these things are also happening simultaneously. Okay, but in this case this is offline, so the chips are not going to be in active mode. So what you can do, you can use multiple chips all together, and you can test if the fault is there in some specific chip. So how you will be testing? This is the BIST controller. You can see the test generation in ORA. This is controlled by this BIST controller along with these distributors. Now, in order to identify that which chip is having this particular fault, you have this chip controller also. Okay, so one signal is going to control the chip also. So that's how you will be able to identify. So you may be using the multiplexer in order to identify multiplexing and demultiplexing system in order to identify that this is corresponding to which chip. If you are finding a fault, then this is corresponding to which chip, that can be identified altogether. So this one was centralized or separate BIST. So centralized or separate BIST, and next one is distributed separate BIST. So in this, every CUT is having the ORA. So both of these types can be possible in your offline BIST architecture. Another one is distributed embedded. This is built along with the chip. So chip is there, TPCs and ORA, all these are there along with the CUT, and this all will be on board. This will be along with your chip, along with your system. So this will be, I mean, lifetime it will be there with the chip. So whenever there is a fault, it will keep on checking that continuously and it will keep on monitoring. So this is actually better than the others. Factors affecting the choice of BIST. So out of discussed BIST, which architecture you must be using, there are different factors. So first one is the degree of test parallelism. How many tests you want to run in parallel? So that degree. Fault coverage, how much fault coverage is there? Level of packaging, if the chip is very small, very big, or where it is used, how much is the payload, and all these things. Let's say we are talking about nanosatellite. So nanosatellites means we have to keep the load as minimum as possible. So if the BIST architecture is too heavy, we will be avoiding that. Test time, how much test time is taken by the BIST architecture, this also makes a difference. Complexity of replaceable unit, कितना कॉम्प्लेक्स है रिप्लेस करना, दैट ऑल्सो मैटर्स. फैक्ट्री एंड फील्ड टेस्ट एंड रिपेयर स्ट्रेटेजी. Performance degradation, area overhead means how much extra area is needed apart from the active area of the chip. Let's say this is the CUT area and this is the BIST area. So sometimes it might be possible that you can bear with this area, but every time you can't. Okay, I can give you one example. For example, you have a phone. So the phone is a handheld device, right? So in that you can fix one more chip, no problem. Your chip size in the phone is very small, and if you are putting some extra circuitry, then also it is not making that much of difference. Now let's talk about uh, heart bit rate, or the pacemaker machine. So pacemaker machine you have to implant inside the body. So inside the body we don't have that much of free space that okay we can instead of 1 centimeter we can go for 1.2 centimeter or 1.1 centimeter, like that. It makes a lots of difference if size is getting increased. So there we need minimum possible area, right? But along with that, since the implantation of the pacemaker cannot happen on daily basis, we cannot take it out on the daily basis and check whether it is getting failed or not. If it is getting failed means the person is going to die on the same day. So what we have to do, we have to make sure that all the functioning is going to work in a good fashion. If there is some fault, then that has to be transmitted on time. So although nowadays it might be possible that we will be having communication for pacemakers, but means as far I know, there is no communication from the inside device to the outside world through anything, so that it can give us the signal, okay, we need to replace it, we need to recharge the battery or something else. Okay. So these are the references. This is the book I told you, and these are other BIST architectures, specific BIST architectures. As I told you, you may go to chapter number 10, 11 in order to read more details about this. Centralized and separate board level BIST architecture, built-in evaluation and self-test architecture, random test, LSSD on-chip self-test, self-testing using multiple input signature register and parallel SR SG. So these are different architectures, and these are a little more about this. So among these in your syllabus, BILBO is there. BILBO is built-in logic block observation. So built-in logic block observation itself is having different varieties like distributed, embedded, combinational kernels, chip level, clouding of circuit, registers based description of circuit, and Bilbo registers. So this is the Bilbo register architecture. In this you can see there is a multiplexer, and this is B1, B2. These inputs are there. You can see this is the XOR unit. These inputs either from B1 or from B2, it is coming over here, and through the multiplexer it might be the input signal or it might be the feedback path. So this is coming here. We call this as Bilbo registers. This is a little bit different from LFSR. So in this B1, B2, two bits are there. What is the functioning of two bits? If it is 0, 0, this will be working like this built-in logic block will be working like a shift register. If it is 0, 1, then it will be working like reset. If it is 1, 0, this will be working like MISR, multiple input, LFSR. If it is 1, 1, it will be working like parallel load, normal operation. So how that will be working, that you can understand easily with the help of this logic diagram. 0, 0. If this B is 0, B1 and B2, both of these are 0. So look at this, the AND gate is going to give you 0. This is also going to give you 0. So both of these are going to give you 0, 0. Sorry, this is OR gate. Look at this is OR gate. OR नहीं है, NOR है ये. This gate is NOR gate, sorry. This gate is NOR gate. So if this is 0, it means the one terminal of everything becomes 0. 0 here, 0 here, 0 here. So whatever input you are getting from the other terminal of the XOR gate, that will be there the output. A XOR 0, you will be getting A. So whatever you will be having from here, that will be available at the output. So B2 is 0. B2 is also 0, means this branch is also completely 0. So output of this will be whatever Q is there, because this every time it is connected to Q bar. So this will give you Q. Every time it is going to give you Q. Got it? And what it is going to give at the input, at input you are having a multiplexer. This is 2 is to 1 multiplexer. So if this was 0, it means the selection is the new input, which is the signal input. SI is the signal input. So this signal input is going to appear over here, right? This is going to appear over here, right? So whatever the signal input is there, that is going to appear, but in the inverted format. So that is going to टेक प्लेस ओवर हियर, यहाँ पर ये आ जाएगा, वो अपोजिट फॉर्मेट में आ रहा है, इसका मतलब C1 इज इक्वल टू 1, दैट इज C0 इज इक्वल टू 1, तभी तो एक्सोर गेट से दिस विल गिव यू द अपोजिट वैल्यू। इफ यू रिमेंबर द LFSR स्ट्रक्चर, LFSR स्ट्रक्चर में क्या होता था, द C1 C0 जो लीस्ट काउंट होता था, देर वॉज एक्सोर गेट एंड द इनपुट एंट्री वॉज फ्रॉम हियर, so this was essentially one, I told you C0 and Cn, these are 1 1, then only the complete shifting is happening. So if C1 is 1, then XORing with anything, Ci XOR with 1, what you should get, क्या आना चाहिए, Ci bar. So that's how the first one is going to give you just opposite of Ci, because this is going to make this functioning, ये जो आपका है the input pattern, this is going to make it functioning, so that's how this is going to give you the opposite value. So here from here you will be reaching through this, and this will be your nothing but SI bar. As we have already discussed, the SI bar we came from C0 is equal to 1, and this will be pushed to this first flip flop, and whatever the input was stored over here, that will be pushed यहाँ से the opposite value of that, q bar का opposite value is q, so basically q is getting pushed to the next one. So likewise at 0 0 level it is working as a shift register. ये समझ में आ गया कि नहीं आया है? Type yes if understood, if need to repeat type no. If you understood whatever we have discussed, type Y. If I need to repeat it, you have to type no. Extras, no. Yes, what about others? Okay, extras. No, 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 no. The strength of no is more. So I'll be repeating this for you. Okay. So I'm just opening the circuit. What we have to do, you just
Ma'am, your mic is off.
sorry. So the first one is shift register 00 entry. So I am just opening the circuit. What you have to do, you just think that if we are applying 00, then what will go, what this will act like. This is bilbo. Bilbo is built-in logic block. ठीक है? So ये how this logic block is behaving if both of the bi inputs are 00, that you have to think. तो एक बार इसको पेपर पेन से यू मे रिड्रॉ द स्ट्रक्चर, इसको सिंप्लीफाई कर लीजिए, जस्ट पुट 00 एंड सिंप्लीफाई इट इन टर्म्स ऑफ एक्सोर गेट एंड फ्लिप फ्लॉप्स। सिर्फ एक्सोर गेट और फ्लिप फ्लॉप्स के फॉर्म में इसको सिंप्लीफाई करके अपनी नोटबुक पर एक बार लिखने की कोशिश करिए, एंड देन इट विल बी अंडरस्टूड इन ए बेटर वे। यस प्लीज टेक ए मिनट, जस्ट 1 minute, and then I will be discussing this again. So I hope you have tried it with the paper and pen. So now let me try it for you. देखिए, what I'm going to do, I'm going to simplify this. ठीक है, जितने भी एक्सोर गेट्स हैं उसको एक्सोर गेट की तरह आई विल बी रिप्रेजेंटिंग. जीरो है उसमें, और गेट एंड गेट हट गया, आई विल बी रिमूविंग दैट. This is my job. Fine. So this is 0. So if this is 0, can I remove all these things? Can I remove this as well? Because 0 means nothing, right? 0 means what? 0 means the XOR gate is having 0. So one branch of the XOR gate 0 means it is nothing. Yes or no? What you have to do? A XOR 0 is A only. So can I do the direct connection from this to this? Yeah?
Yes, ma'am.
So it will look like this. You are having all the flip-flops like this. Okay? And one NOR gate is there. NOR gate is everywhere. The NOR gate is coming from this side. यहाँ से है. So one part of the NOR gate is this 0. Another part you are getting, इसको first वाले को छोड़ देते हैं अभी. This is a multiplexer. Another part you are getting from Q bar. Right? So what will be the output? Q bar plus 0 and whole bar of it. What will be the output? Q, right? Yes?
Yes,
Yes or
ma'am.
no? So can I say that I can have a direct connection from this to this effectively? Yeah? So in a simplified manner, it will look like this, that the Q of every D flip-flop is going to be like this, and the input is the SI. The input was taken from the SI, and this is getting, ये देखिए, because this B1 was 0, so this 0 means through this it is going to be at the output. Okay, so whatever SI was, you will be getting SI bar, right? So this SI bar is available at the input of the first D flip flop. So SI bar is the input, and in this fashion you are getting all the D flip flops. Okay. So if this is pushing a new input to this input is shifted to this to this to this, and then the final the output. So what is this? Can I say this is a shift register? Yes or no? Yes, Raj, Abhinav,
Yes, ma'am.
समझ में आ गया?
Ma'am,
Okay.
I got it.
Now likewise, let us have a look at the another mode. हाँ बोलो, कुछ पूछना है? Somebody wants to ask something? No? No? Then let's proceed. So the next mode is 0 1. How it will be working for 0 1 mode? So let's have a look for the 0 1 mode. So the 0 1 mode is like this. First one is 0, B1 is 0, and B2 is 1. So this is going to reset. This is going to reset all the values. So how it is going to reset? Let us have a look at this. So 0 is this. It means the selection, this is 0, and this is 1. So if this is 1, so irrespective of everything, what will be the output of NOR gates? क्या आएगा NOR gates का output?
0.
0, right? क्योंकि because this B2 is 1 and this is 0, so from here you are getting 0, here you are getting 0. XOR output, what you will be having? Every XOR will be having 0 output, and this 0 output is the input for the next cycle for the registers, right? So everywhere you are pushing 0, so every register will be having 0 0 0 0. So it means the register data is reset. That's why we will call 01 is the reset mode. आ गया समझ में?
Yes, ma'am.
Everyone? Very good. Third one is MISR, multiple input shift register. So multiple input shift register, how it will be working? 1 0. The mode is 1 0. So this is somewhat like LFSR, but multiple input entries. So let us have a look for this. So this is going to give you 1 0 entry. One here at B, here it is 1 and here it is 0. So if this is 0, it means everywhere this is 0. So whatever, as I told you earlier, this q will be reflected over here as, this q bar will be reflected as q. यहाँ पर this was, see this is 1, so whatever you were having over here, the opposite of that will be appearing over here. So what exactly was here, just have a look at this. This was qn, and the XOR of all these bits, the opposite of all these bits is taken, and this is XORed, and then it is going to the input of this. ठीक है? और यहाँ से whatever you will be having, just opposite of that you will be having over here. This was 1, so this is 1. Correct? This was 0, so whatever q bar is there, this is appearing as q. So यहाँ पर क्या आएगा? 1 XOR with q, you will be getting q bar. Yes or no? आपको क्या मिलेगा यहाँ पर? Every time you will be getting q bar. Here directly you will be getting q bar. Everywhere q bar you will be having. So this is actually the opposite entry. जो आपका q shift होना था उसका opposite है ये. First thing is this, right? So second thing is what you are having over here. So depending on what was the value of q bar का क्या वैल्यू था, उसके करस्पॉन्डिंग द करस्पॉन्डिंग OR गेट विल बी ऑन और ऑफ. ठीक है? इफ q bar is 0, it means the corresponding ci is equal to 0. If qr is 1, that means corresponding ci is equal to 1. And correspondingly, whatever your LFSR architecture was, that will be working for that. So here you are able to see the uh, input of every register is getting updated, and the main input is pushed toward this. So this is working like multiple input shift register. Next one is the parallel load, which is the normal operation. So how it is working like a parallel load, let us have a look. Both of the inputs are 1 1. B1 is 1 and B2 is also 1. So BILBO I have also given you as assignment. So you may write few things about BILBO in that. Since I am taking this in the class, so don't write much about that, because I might not be asking that in this presentation. The topics which I am not going to cover, that I will be asking definitely for the presentation. Okay? Okay. So here, 1 1 operation means this is 1, this is 1. If you look at this, this is another entry. Okay. 1 1 means this is the other entry. राइट? अच्छा, हाँ, इसका मल्टीपल इनपुट कहाँ से बना था? सो मल्टीपल इनपुट इज कमिंग फ्रॉम this was 1 na, so the another input you are getting from this. Actually this is not always 1. Whatever input you will be having, that input will be visible over here, and then XORing with this you will be having the new input data over here. That's how this is the multiple input. Now in 1 1 means it is the parallel load. Load operation means this is 1, this is 1, that is going to appear over. This is also 1. It means irrespective of whatever you are having over here, this is going to provide 0. Means the another terminal is inactive. So whatever you are getting from here directly, that is getting shifted to the flip-flops. Okay, so this is known as the parallel load operation. So the all other circuits will be inactive. And this complete, you can say there is the direct connection of this input to the D flip flop. Yeah. So this is how the parallel shifting operation is taking place. And in the next cycle, you can take the parallel data at the output also. So parallel in, parallel out. This is also a kind of register. So this will be working, this BILBO will be working like that in that case. Yeah, समझ में आ गया. So these are the four reasons of operation for bilbo, sorry, modes of operation we must say. These are the four modes of operation. 00 means shift register, it will be working. 01 means reset. 10 means MISR, and 11 means the parallel load, it will be working like. Now what are the different applications? So these are the different applications, like bus oriented structure. You will be having bus oriented kind of a structure. So it is given over here. It will look like this. Another application, pipe oriented, pipeline oriented structure. So in the bus oriented, you have different structures altogether. And in pipeline oriented, you will be having pipelined, means sequence one after other. Okay, C1 is there, C2 is there, bilbo is there. So then another BILBO is there, another chip is there, and likewise the primary outputs will be available over here. What are the problems faced by bilbo? So problems faced by bilbo are somewhat like this. Through this circuit, input is taken, and then the output of bilbo is going to the input of this. So mainly actually first thing is the complexity and overhead problems are seen. So generating the test pattern, that is also the issue. It is generating all or not. If it is generating, then these are generating complete test pattern or not, that is also the issue. So this is a transistor level implementation of CBILBO. So this, you can see the transistor level implementation. Sorry, transmission gate. These are the transmission gate, and this is nothing but the D flip flop master slave. Whatever the block we have seen earlier, two D flip flops. This is the same. So you can just see this structure and understand it, how it is working, just like a D flip flop. Okay. So how it will be working, like test pattern generation mode and MSIR mode, that is given, that is by the set of inputs it will be working. MISR is actually just like your LFSR, which is basically used like test pattern generator as well, and the signature analyzer as well. So depending on that, the same block will be working like for both of the units, TPG and the output response analyzer. So combination of LFSR and scan path. So these can be the possible combinations: LFSR, then scan path, and this is the signature analyzer. This is nothing but ORA. And another thing is CUT. The scan path is communicating with CUT, and the same scan path is communicating with both of these, LFSR and signature analyzer. So the problem is with this, hard to detect faults, means corner case bugs cannot be acted upon. So this is the example given for this. So here this is shown that this stuck at zero fault can never be detected. And this is the example of LFSR. So you can just do the exercise on this, and then you can figure out why this fault is not detectable. And this is the other example. These examples you can find in the books also. So these are the solutions for this. These are given in the next chapter. We'll be working upon this. Okay, so let's stop for the day. It is 10 o'clock. You might be having other class. And tomorrow, 8 o'clock, we have the scheduled class. Can you hear me?
Yes, ma'am.
Yes, ma'am.
Yes. Right. So tomorrow the scheduled class is 8 o'clock, but since I have seen last 2 to 3, you know, Thursdays I have seen the strength is very less. So I request everyone of you to submit your assignment number 2 class on 9 a.m. Friday. Is it fine? Is it fine for everyone?
Yes, ma'am.
So those who are having the objections may submit the objections to Sukriti. She will be forwarding the objections to me because 8 a.m. tomorrow, Thursday 8 a.m. I'm not able to see much of you. So that is not really good. And today also the class strength is really very less. I'm also collecting the attendance, so it might be creating a problem for you. You just need to sign in. I don't know how many of you are getting something or you are not getting or you don't want to get कि क्या पढ़ाया जा रहा है छोड़ो क्या करना है ठीक है सो वट एवर इट इज बट एटलीस्ट आपको साइन इन होना है अटेंडेंस के लिए वो तो कर ही सकते हैं राइट ओके सो थैंक यू सो मच विल बी मीटिंग 9 a.m. डे आफ्टर टुमारो
Ma'am,
हाँ बोलो
ma'am, when are you going to assign the topics? You said I will assign each and every student with a the specific topic.
So, right. So I have given you 20th or 21st till that you have to submit your assignment number 2 online. ठीक है?
Okay, ma'am.
So maybe on Friday I can assign you the topics and Saturday morning I will try to schedule at least for 2 hours I will be scheduling otherwise हमारा नहीं हो पाएगा. ठीक है और मैं उन लोगों की लिस्ट और टॉपिक्स मेल करूंगी आपको ठीक है सो आई रिक्वेस्ट एवरी वन ऑफ यू टू सबमिट इट बाय टुमारो लेट नाइट और डे आफ्टर टुमारो मॉर्निंग ठीक है submit the assignment written
Okay, ma'am.
assignment by tomorrow late night or day after tomorrow early morning till that you have to submit and after that means this Saturday onwards I will be working on the presentations so during the presentations your presence is required everyone has to be present along with the presenter ठीक है okay thank you so much I will be meeting day after tomorrow thank you
Thank you, ma'am.
Thank you, ma'am.
welcome bye have a nice day